Hello everybody. This video will deal with the tnc-x and the receiver portion of it, and we will deal from the schematic level. So let's get started. First of all, a little color about schematics. As design engineers, you need to become very comfortable with schematics. My experience is that most students like to look at the physical drawings or the physical layouts, but as we go to smaller and smaller components, it is very difficult to get a feeling for what's in the circuit from a physical point of view, and you need to get very comfortable on the schematics, and we'll attempt that in this video. So let's get started. And now this is in the last video we talked about in high-level terms how the receive portion of a TNC works. Now we're going to look at the schematic level, right? So the audio signal comes in right here from the receiver. And remember, there are tones in here, 1200 and 2200 tones coming in here. And this is just an op amp. And if we were modeling these parts, we could model this as an op amp with a feedback loop. And this is a filter, so the tones come in here, and it's a relatively noisy signal coming in here, and this filters out some of the noise. So the audio signal actually comes out right here and proceeds to through some components in here to what we call the modem chip. And this is an MX614, and you can look that up, the data sheet, online. So tones come in here, 1200 and 2200 hertz tones, and this chip actually will convert those tones into DC levels, and I'm looking for the DC level, and I'm having a little trouble finding it. It's one of these signals over here that goes to the PIC, and I believe it is RxD right here. So in review is that audio comes in here and DC comes out over here, ones and zeros. The 1200 hertz tone here may be represented as a 0, where 2200 hertz tone over here may be represented as a 1. And of course, these are some control signals. This is an oscillator that drives this thing, and these are control signals, and you can look them up on the web. Actually, this is a duplex strip because it takes data in and puts out tones, but we're working on the receive portion today. So out comes tones over here going to our PIC, and I got to go gain control of the mouse to kind of slide over here, and I'm going to blow this up just a little bit. So let me go grab control of the pin again. So the data comes out on RxD, and I may have gotten the error wrong on the long line. So out here comes data in forms of zeros and ones, and gets over here to one of these inputs on this PIC. And this is a 16F628 chip. All right, and what this does is format the data into x.25 packets. So raw bits come out over here. This thing recovers the timing and things like that. And this is just a plain PIC, and this is just a piece of a chip. It's an SRAM, and you can look this up. This is an FM25, excuse me, an FM5256 RAM chip. And out of this chip comes TTL data that's in ASCII format. So binary data over here comes in over here, X25, excuse me, AX25, KISS mode mode data comes out over here, which goes to the main USART port on our satellite COM board. So that's it for this portion of the video. See you in the next video.